do this online lesson for the day. Today we're going to be covering measures of central tendency and measures of dispersion. So it'll take a little bit, but we're going to break this up into a few chunks, so make sure you watch all the pieces that come out of this video. The first thing, of course, is measures of central tendency, and we're going to define data as a collection of information, usually numeric, it could be names and other stuff, from a study or an experiment. For example, if we have 15 test scores, I could just list out each person's grade, and that would constitute a set of data, or just plain old data. Now, statisticians will call the whole set data and each individual number data. I like separating it away and go back to set notation and call the elements, the numbers of this data, to be called elements. It's one of the data values. For instance, the 66 is an element of this data. Alright, and we're going to do some calculations based on this set to start off with. For instance, we're going to find the mean, and the mean is just the sum of the data elements divided by number of elements. And this is the same calculation as what you're used to by taking the average. But average has different connotations, so saying the mean really specifically means add up all the elements and divide by how many there are. For example, if we want to find the mean of this following data set, we would take all of the numbers. The first thing I would do is find out how many there are, and if I remember right, there's 15 of these. Yeah. So we're going to take up all of these numbers, we're going to add them all up and divide by how many. So here I'm summing up all the top numbers and dividing by the number of them, which is 15. And if we do this calculation, we're going to end up with 1,138 divided by 15. Of course, I'd rather the answer as a decimal, and the rule for rounding is if there are no decimals on any of the original elements, then you round to one more decimal of accuracy. So the decimal answer comes out to be 75.866667, and since these had no decimals, we're going to round our answer to one decimal place. So the mean, in this case, is going to equal 75.9. So the mean score of this test is a 75.9. The next calculation we can run on this data set is called the median, and the median literally is the middle of the data. So this means a few things have to be true. The data needs to be in order, numeric order, and the middle number can either be a single value, depending on certain cases, or it could be between two different values. Single values will happen when we have an odd number of data values. Between two values will be when we have an even number of data values. So in this case, we're talking about 15 elements again. So we're going to say n is equal to 15. So n is going to represent the number of elements, kind of like the cardinal number. Now, if we're going to do the median, we have to take each one of these data values and put them in order. So you'd start off with 61, and then 63, and then 65, and so forth and so on. Eventually you'll come out to be this list, 61, 63, 66, and so forth and so on, always increasing in value. Make sure when you do this that you have the original 15 numbers listed out. One way of checking is to actually just count how many you have when you get this new list. Now, to find the median, to find the middle, you can do it two different ways. The long way would be, you mark off one here and one there and one here and one there, and eventually you'll get down to the middle number, or the middle two numbers. But an easier way to do it is to use the median formula, which is basically just n over 2. n in this case is 15. 15 divided by 2 is 7.5. And because it landed on a decimal, we're going to push it up to the 8th element. And all you have to do is count out to the 8th element. So here's the first element, there's the second, third, fourth, fifth, sixth, seventh, 8th. And this number becomes the median. So the median of this data set is equal to 71. Alright, if we have a even n, where n is even, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. So in this case, n is 12. The first step, of course, is to get the numbers in numeric order. So the smallest number here is 60. I like doing the cross-out method. The next number up is 63. I'll use commas to separate. Next number up is 74, then 75. So that one's gone, that one's gone. Next number up is 81. 87, 88, 87, 88. That leaves 91, 95, 97, 95, 97, and then two 98s. It would be nice to have all those nice high test scores. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have all of them. And we're going to use our little formula, n divided by 2, and there's 12 of these things, divided by 2. And when the answer to this comes out to be a whole number, you're going to pick the 6th element and the 7th. In other words, it falls between the 6th and the 7th element. So here's 1, 2, 3, 4, 5. So it falls between these two numbers, 87 and 88, the 6th element and the 7th element. So what we're going to do is we're going to say that the median, in this case, is going to be the average of these two numbers, because it lands someplace in between them. So 87 plus 88, to find an average, you divide by 2. So this turns out to be 87.5. So the median of this data set is 87.5. Not too bad. So you're going to divide by 2. It's going to come out, an odd number of data points. You're going to divide by 2. It's going to come out with a decimal, and you're going to round it up and just pick one number. If you have an even number of data points, you're going to do the n divided by 2. It's going to come out a whole number, and you pick the next one also. You pick two numbers when it's even. All right. Mode is probably the easiest one of all. It's the elements that occur the most frequently in a data set. Again, just for if you're going to do mode, you usually are going to do median. So you put the numbers in order, and all you have to see is if any elements are repeating. And here the 71 is repeating 3 different times. I don't think anything else is repeating. Now modes can have two answers. Like if 66 happened 3 different times, we would say the mode was 66 and 71. But in this case, the mode is just 71. And that's it. Mean, median, and mode, simplistically. All right, data can come in tables. So in this case, I have some scores here, a 55, a 60, a 65, a 70, and a 75. And out of my class, I guess you could say, 4 people got a 55, 7 people got a 60, 3 people got a 65, 11 people got a 70, and 5 people got a 75. So these numbers over here are not data points. They're just the number of occurrence of the data points. X is always going to represent data, individual data, or elements. You can think of it that way too. So if I want to find the mean of this, it's still going to have the add them all up and divide by how many. To find out how many we have, we're going to just take the frequency and add them all up. And I'm going to get you used to some notation. This symbol is called a summation. It just means add them all up. So the sum of the frequencies is going to equal what we've been calling n, the number of elements. So if we add these all up, we're going to get that the sum of the frequencies is equal to 30, or the number of elements is 30. At least I think it is. That's 11, that's 22, 25, yeah, 30. So in this case, the mean is going to equal, well, it's going to get divided by 30. So we have to kind of think of it this way. There are 4 55s, so you'd have 55 plus 55 plus 55 plus 55. An easier way of doing that, of course, is 4 times 55. And then we're going to add on to that, there's going to be 7 60s. So 7 times 60. And then 3 times 65. So it's always going to be the frequency times the data point, or the element. Plus, I'm going to run out of room here, 11 times 70. And eventually plus 5 times 75. And we're going to take this entire sum and divide it by how many, which is 30. A quick way of writing the formula for this is the summation of the frequency times x divided by the sum of the frequencies. Alright, let me do this calculation. So here we have the top number, the sum of those products and whatnot, is 1980. And we're going to divide that by the number of elements, which is 30. So the mean comes out evenly as 66. But to show that I didn't round to 66, I'm going to put a 0.0. So the mean of this frequency distribution is 66. Alright, if we want to find the median of this frequency distribution, it's a little different. We're going to do what's called a cumulative frequency. Basically all it means is we're going to subtotal it up as we go down. So we're going to start off with 4. The next one is going to be 4 plus 7, which is 11. The next one's going to be that 11 plus the 3, giving us a total of 14. And then it'll be 14 plus 11, which is 25. And then finally we're going to take the 25 and add up the last 5. So this is just called a cumulative frequency, adding them up as we go and writing their answers down. And what's nice about the cumulative frequency is it gives us the number of elements, so we know here that n is equal to 30. And then we can find the median by doing the n divided by 2 formula, which is 30 divided by 2, which comes out to be 15. And we'll take the 15th element and the 16th element. So as we go down the cumulative frequency, the 15th element is not here. It's definitely not there. It's definitely not there, so it'll have to be the next one. So the 15th and the 16th happen here because this goes all the way up to 25. So the 15th and 16th is happening when the data is 70. So we say that the median of this table data is equal to 70. Part 1 complete.